अशाच प्रकारच्या दर्जेदार व्हिडिओ पाहण्यासाठी आमच्या चॅनलला सबस्क्राईब करा आणि नोटिफिकेशन मिळवण्यासाठी बेल बटनला प्रेस करा.
Hello friends, I am Pramod Deshkari and we are going to discuss the analytical part of MPSC questions. This is a question number 61. What is the value of current flowing through the 6 ohm resistor, that is nothing but the R4. So to determine this particular part we can use a Thevenin's concept, and according to that particular part the load current, that is here the current I is nothing but the Thevenin's voltage VTH divided by the specific resistance RTH, Thevenin's equivalent resistance, plus load resistance RL. Here load resistance RL is nothing but the 6. The first process is nothing but to disconnect the load from the circuit to determine the specific value. So what is VTH? VTH is nothing but the voltage drop across this terminal, and voltage drop across this terminal is nothing but the voltage drop across 8 ohm resistance. So here to determine this voltage we must know the current flowing through this particular path. So according to that one we can determine the specific current. So applying a simple law over here, we'll just have the total voltage. So this is nothing but the current I is equal to total voltage, that is a 12 volt, divided by 2 resistances are in series. So 8 plus 4, that is nothing but the 12. So this is nothing but the ohm. So we just have the total current flowing through this is nothing but the 1 ampere. Now we got the 1 ampere current which is a flowing through this resistance. So that's why the VTH, the Thevenin's voltage, is nothing but this voltage. This voltage is nothing but the current flowing through that particular path, that is nothing but the 1 ampere current multiplied by this 8 ohm resistance. So this is nothing but the 8 volt. So we just have the VTH 8 volt. Now the Thevenin's equivalent resistance. To consider the resistance we have to short circuit the voltage. So we'll just short circuit this particular resistance, and if we just consider this is nothing but the pure passive component, that means resistive network. So these two resistances are parallel with each other and this is in series with that particular part. So from that calculation, so RTH, when we just solve this particular part, we'll just get the total typical value of that resistance, and it is nothing but the specific 4 ohm. So after simplification of that, we get the value of 4 ohm. We'll not solve that particular part over here, but here RTH is nothing but the 4 ohm. If we put the value of VTH and RTH in this equation, we get the current flowing through the 6 ohm resistance is nothing but the total VTH, that is the 8, divided by RTH, that is nothing but the 4, plus RL, here load resistor is nothing but the 6 ohm, so this is nothing but the 6. So this is a 8 by 10 and this is a 0.8. This is the answer key for that. So this is nothing but the specific first question, which is the analytical part of that one, and the correct answer for this particular part is nothing but the second. This is nothing but the basic idea for the first question. Now we'll just try for the specific part, that is nothing but the 62. In this particular 62, the question is number of equations required to analyze in a given network by a nodal analysis. So this is regarding to the nodal analysis. For nodal analysis, we always know that the number of specific equations should be 1 less than the number of nodes. The option is nothing but the 4 for that. So this is a specific conceptual part, no need of any analytical part. The last point is nothing but the specific part, the 1 less than the number of nodes. Then question number 63, this is according to this particular part. There is some confusion regarding to this particular part because 2 capacitors are connected in series. So this is a C1 and C2. Resultant capacitance is nothing but the C1 C2 divided by C1 plus C2. So this is a resultant equivalent capacitance in series. And what is the question? the particular question is relates with the maximum energy stored. So maximum energy stored is nothing but the half then CV square. If we put the values over here, you will get the answer, but there is a specific part related to this. So definitely you should ask or release or this particular part you can refer from the MPSC keys. Then third one, next particular question 64. This is a question related with the admittance. Why? Admittance is always reciprocal of impedance. So this is nothing but the particular reciprocal relation between the admittance and the impedance. What is given in this particular equation? That Z bar is given, and that is nothing but the specific value 3 plus J4. Now what is the specific question that the admittance of this particular part, that means Y, is nothing but the Z divided by Z mod. So here what is Z? Z bar is 3 plus J4. So Z is definitely 3 minus J4 divided by the mod of this particular Z. While calculating this part, we use square root of 3 square plus 4 square. So if we simplify, this is nothing but the 3 minus J4 divided by this is nothing but the 5. If we simplify this particular part, so this is a 3 by 5 minus J4 by 5. After simplification, you will get the exact answer, that is a 0.6 minus J times 0.8. And the unit of this particular admittance is nothing but the mho. So this is a specific key for that question number 64. It is given as a 4. The next question, which of the following three-phase system is sometimes also called as a three-phase 4-wire? So here the representation is just like this one. So these are nothing but the star connected, one terminal, second terminal and third terminal. When there is a neutral terminal drawn outside, we get three-phase 4-wire system. And it is applicable only for the star network. That's why for question number 65, the answer key is nothing but the one, that is a three-phase star connected. Next question, that is a question number 66. Three similar resistors are connected in star across 400 volt and three-phase lines. The line current is 5 ampere. Calculate the value of each resistor. So that is, structure is like this. Three same value resistors R and R are connected across a supply, that is a three-phase supply, and voltage is given, that means VL is given. So this is a line voltage. How much line voltage is given? Line voltage is given is 400 volts. So definitely line current is there. But in this case, when we use a star connected three-phase supply, line current is always equal to the phase current. And line voltage and phase voltage is different. So here phase voltage is line voltage divided by root 3. So if we simplify this by putting this particular value, so we get VPH. If you put that particular value, 400 divided by root 3. And in the same manner, IL is there. So value of R is nothing but the phase voltage divided by phase current. If you put all this particular value, we'll just have this particular value of R is nothing but the specific 46.2 ohm. So after simplification and calculation part, we get the answer 42.2, and this is nothing but the 66. So this is answer key is nothing but the 1. After putting all this particular value, we will get the idea. Now question number 67. Question number 67, again it is a theoretical specific concept. In a transformer, maximum voltage regulation is relates with the induced EMF and average voltage. This is nothing but the specific E2 minus V2 divided by E2 multiplied by 100. This is nothing but the percentage regulation, and this is relates with the lagging power factor of the load. So this is the option 2, lagging power factor of the load. Question number 68. Question number 68 is relates with the losses in transformer. The core of a transformer is assembled with a laminated sheet. Laminated sheets are used to reduce the eddy current loss in any transformer. That's why the option 2 is correct for this. So that is nothing but the reduce the eddy current loss. So this is option 2. Then question number 69, last but one question. So again it is somewhat, we can say, that tricky question. That's why you should go for the MPSC site for exact key. The last question, that is nothing but the question number 70. Here, what is the question? The resistance and reactance and capacitive reactance, XC, and this is a R. So this is nothing but the resistance and capacitive reactance are in series circuit. Its value is 7.5 ohm, and the value of capacitive reactance is also 7.5 ohm, both having the same value. RC connected in series, so this is nothing but the RC series network. And what is that question? In this particular circuit, what is the relation between current and voltage, and what is the lagging angle for that particular part? So here, if we plot the vector diagram, so in this case we know that in RC network circuit, resistance, that means particular current, always lead voltage, and that particular representation is like this. If we consider this is a resistance, and if we consider this is nothing but the reactance, then the resultant is nothing but the impedance Z. The angle between this resistance and reactance, suppose say theta. In this particular case, if we mention tan theta relates with the opposite side, that is XC, divided by the resistance. Therefore, theta is nothing but the tan inverse of XC by R, where value is nothing but the 7.5 and 7.5. So tan inverse of 1 is theta, therefore theta is nothing but the 45 degree. And we know that current always lead the voltage. So current lead the voltage by 45 degree. The option for that is nothing but the second. So question number 70, second. So all these are nothing but the option keys related to the electrical question paper. Okay, it's all. Thank you.
अशाच प्रकारच्या दर्जेदार व्हिडिओ पाहण्यासाठी आमच्या चॅनलला सबस्क्राईब करा आणि नोटिफिकेशन मिळवण्यासाठी बेल बटनला प्रेस करा.